Good morning. In previous lecture, we have discussed about the introduction of operating system. That what is the operating system, how it acts between the interface between hardware and the user application. Now, in previous lecture, I have also discussed about the functionalities of OS, about storage management, up to the storage management. But in this, I am giving a brief introduction of all the functionalities of the resource management. What is the resource management and all the major functionalities of the operating system. So, the major functionalities of the operating system, the first one is the resource management. So, as we know, the operating system which we are using in our daily life, just like a Windows operating system, we use the parallel tasks in our operating system. Like we are using some multiple programs or multiple processes are continuously executing in the CPU. So the responsibility of the operating system is to manage all the resources which are used by the operating system, and acts as an interface so that we are not get halt, or the system get halt, or the system get like busy or in a sleep mode, so that one resource have to wait for the another resource. So it is just like as the interface in parallel access, multiple user accessing the hardware or particular system in server level. So OS works as a resource manager. OS works as a resource manager. OS works as a resource manager, and it easily manages all the resources which the operating system uses. Suppose if we are using the RAM memory and some task is executed in some task process comes in the main memory, and then it gives to the CPU for executing that process. So after the execution of that process, it will not remain idle in that main memory. It will get deallocated. So it will so the proper resource utilization is to manage which resource has to allocate and which resource have to deallocate. So this is the main concept of the resource management. When we switch on the computer and it goes to the task manager, we can easily find out. When we go to the actually viewing the if we want to view the how many processes or how many resources our system is consuming, our operating system is using, we can easily access to the task manager. From task manager you can easily say the process, many processes are utilizing the main memory, and in that we can easily see the CPU utilization, in which you can easily see the utilization of the CPU. It shows some graph of something like that, in which the process are continuous. It is between the time and the number of process. It is between the time and process. So you can see that the CPU, how much CPU utilization if the for number of processes are increased, and in that time period what is the scheduling of that CPU, how the CPU schedules that process with using the different algorithms to make it in an optimized way. Next thing, task manager, in which we can see the CPU utilization and also see the memory usage. Memory usage means the process which is coming to the main memory for executing purpose, how much memory is allocated for that process to be, which may get to the CPU for execution purpose. So in that we can also see that the resource, so the responsibility of managing the CPU utilization and the memory usage is the responsibility of the operating system. So how to manage it and how to make it a better experience so that user can do all the tasks very efficient way. The main motive of our task to do any work in the computer is that we want fast efficiency. We want fast efficiency. So means if we give any process to the computer, we want that the CPU will perform it in a fast way. And we want the fast. We don't want the system to be take much and more time. We want that if we give any instruction, it will perform and it will give the fastest output in that time. So this is all about the resource management. The second is the process management. The second topic is, the second functionality is the process management. So in parallel system we use parallel system we use many tasks like we are using some Word file and we are using some web browser and some media player. Okay, so we are using multiple programs for in an operating system. So which task will have to perform, in which process will have to be executed in an efficient way is the responsibility of the operating system. Is to manage the time duration, is to manage in a multi-programming way so that all the tasks, all the process are executed in a concurrent way and we have to not to face any difficulties in executing that process. So it's a whole responsibility of the operating system so that all the processes can work in an efficient way. So process management, if it is a simple example is this: if we are doing any program in C, and so suppose that if we have done any program in C and save it in .c. The extension, it is the extension of any file and we store it in the secondary memory. Store it in the secondary memory. This is the example which I am showing in the process management. Any program which is written in C, we have saved it in the .c format, .c extension, and stored in the secondary memory, which is hard disk. Secondary memory. Now it is stored in that secondary memory. Now if we want to execute that file, if we want to run that file, we want to run program of C, then what will happen? It goes to the main memory. It goes to the main memory, and this now the whole process will go to the CPU, main memory, and main memory will go to the CPU for execution purpose, in which we say that if we compile the program, just like Control F9, if we want to compile any program, which means the computer or CPU is executing that file. So CPU is now the charge goes to the CPU will execute that file, and then now it's a whole responsibility of the CPU that which scheduling algorithm is used by CPU. There are so many scheduling algorithms which the CPU can perform. For which one example is the round robin algorithm, or we can say shortest remaining time. Many algorithms are there, and the CPU can use any of the algorithms for the execution of that file. So it's depend upon the CPU for executing the process in an efficient manner. So the whole sole responsibility of maintaining the process management is done by the CPU, which will be CPU, and in CPU scheduling will be there for executing that file, and in CPU scheduling there are lots of algorithms which we will discuss in the after later in the future topics in the CPU scheduling, which will be given the exact example of that all the algorithms for which how the CPU will execute any process if the process are coming in a concurrent way, in a multi-programming way, how the CPU will perform that task. So this is all about the process management. I hope you have understand the process management in this way. Now the third is the storage management. So storage management is the storage in hard disk or in the secondary memory. How the files which we are using in C, if we are accessing our hard drive and accessing any file folders located in the C drive, D drive, E drive, which is the secondary memory, how the files are stored and how the hard disk will manage that file, so that if we want to access the file later we want to access any file, we can easily access that file. So the hard disk will manage or store that files in this way. Suppose this is the hard disk and these are the tracks. These are the tracks of any hard disk in a cylindrical way. This is the one upper view of the hard disk. These are the tracks. These are the tracks. These are the tracks. These are the tracks. And between these tracks, there are sectors. These are the sectors. In this way, these are the sectors. These are the sectors. So data is stored in the sectors. In which track and in which sector the data is stored. And for managing all this file, there are many file systems which can manage the files of any operating system. There depends upon the operating system that how these files are managed in different operating systems. So this is the file system. This is the file system of Windows and Linux. In Windows we use CIFS, NFS. In Linux we use ext4, 1, 2, 3, swap, XFS. These are the file formats of operating system which we use in Linux platform. If we are storing any files in the Linux platform, the file will be stored in this format. If we are storing any file in the Windows operating system, the file or folder will be saved in this format. CIFS, NFS, FAT, 32, NTFS. These are the file formats of storing any files in the file system of different operating systems. We will discuss also these file systems of different operating system in the future lectures, I will give the detailed analysis of all the file systems. First, here I am giving you just the brief introduction about all these file systems, that how these file systems are managed between two operating systems. We are using Windows. Then it may be asked which file format supported in Windows format system, Windows operating system, or which file format system is used in the Linux file format system. So you have to know about the different file formats, that ext, that is extendable file, and extendable for type format, and ext is for extended. Ext is for extended file system. Okay, extended file system version 1, version 2, version 3. Swap is also used in which switch between the physical memory and the virtual memory. XFS is also there in the file format system. XFS. And JFS is also journal file system. So when you install the operating system of Linux operating system, when you will get the installed properties, you will see all this file format system, but you can't see this file format system. Okay. In Linux file system, you can access this file system, you can see this file system and can't see this file system. But in Windows, you can access, you can manage the data with this file system, but you can't see this file system. So there is a difference between these file systems, these two file systems. So this is all about the CIFS, is also the full form of CIFS, Common Interface. Full form of CIFS is Common Interface File System. NFS is Network File System. FAT is File Allocation Table. This is also a file allocation table for 32 bits, and new NTFS is new text file system. So these are the file format system which I have given a brief introduction about the storage management. So now you can see this, there is written storage management and memory management. These terms are mostly related. Much students get confused between what is the storage management and what is the difference between memory management. So in storage management, our storage management is concerned with secondary memory. But in memory management is concerned with the RAM, which is main memory. Okay, so there is a difference between the secondary memory and main memory. So managing the file systems which are stored in the hard disk is done by the storage management, and managing the managing the memory of RAM is managed by the memory management. So now what is in the memory management I will discuss here. So in memory there are two things. One is allocation and second is de-allocation. Allocation means when any task comes for execution, when any any process. Suppose if I have written a program in C and I want to execute that file. If you want to execute that program, then If the program is in secondary memory, which will, and it want to execute or compile. For this purpose it will goes to RAM, which is main memory. When it enters in the RAM or main memory, it will change into the process. So the now which is program which is in the secondary memory, we are saying that this is the program. When it enters in the RAM or the main memory, it will convert it into the process. Now when it converts into the process, it will take some space. Like if our main RAM, this is the RAM, and it is about 4 GB space. It will take 4 GB space. Suppose this is the RAM of 4 GB, and if we want to execute, then this process will goes to the RAM and it will take some space. It will take, suppose, 100 KB. It will take some space from 100 KB. Now this is called the allocation. The program enters into the RAM is called allocation, and when it enters to the RAM, it will change into the process. Now this is the process. When it lies in the RAM, it will call the process. Now it will give to the CPU. For what purpose? It will for execution purpose. Now CPU will, what will do? CPU will take the process from the RAM and executes and gives output. After giving the output, the memory which is occupied by the RAM by process gets released. Now there is no use of that process in the RAM, because we have already execute that process and finally got the output. Now this memory will get released. For which purpose? For next purpose. So when it gets released, it is called deallocation. Deallocation means when the programs enter to the RAM, it gets converted to the process. It will give to the CPU for execution. After getting the desired output, the memory gets free, and free means the space required by that process is get released, and it is called deallocation. So in the memory management, the main task is allocation and deallocation. So I think you have got cleared with the clear concept of the memory management, that what is done in the memory management, it is clearly allocation in the RAM, and after execution it will get deallocated. This is all done in the memory management. Okay. Now the next is, so this is all about the memory management. I think you have clear about the memory management and the storage management, that what happens in the storage management and what happens in the memory management. In storage management, we manage the files which are stored in the secondary memory, but in memory management we manage the RAM, because there is a limited size of the RAM. We can't get the space about that the secondary memory have. Like in the secondary memory we have 1 terabyte of space. We can easily store as much data about the 1 terabyte. And if we are having the 1 terabyte hard disk, we can easily store 1 terabyte of space. But in memory, there is a limited space for the RAM. We can only utilize, we have to manage that memory. so that all the tasks can easily done. So this is all about the memory management. The next is the next one is the security and privacy. So the main and very important point is that how our system is secure. When we log into the operating system, suppose we log into the OS like Windows, we get the password. We need password. For which purpose? To authenticate. Authenticate for which purpose? Authenticate means the person is valid or invalid. Person is valid or invalid. If the person knows the password, then only it will authenticate. Otherwise, it will say that the password is wrong. So the Windows operating system, here the Windows operating system uses Windows OS uses Kirby Rose security, which will be discussed in the cryptography or the computer network systems. There is a Kirby Rose of security protocol, Kirby Rose security protocol, which is used for the authentication purpose. So which is used for the security purpose. Now the privacy, what is done in the privacy? What is the difference between security and privacy? So privacy you can easily understand it by this diagram. Suppose this is the RAM, and in which different processes are running. Suppose this is P1 process, this is P2 process. It taking this much amount of space, and here it is taking so this is the all about, and this whole space is 4G. So P1 is running in that addressing, and P2 is addressing in that 201 KB. Here I will mention it to make it clear. P1 is P1 process and address. Okay. Process P1 is utilizing from 0 to 200 KB space, and P2 process is 201 KB to 500 KB. I have just written that about the space in these terms. So if P1, the privacy means if P1 is executing any files, we process having many instructions to go and many instructions to execute. So if P1 file is executing and it needs another file to execute, suppose it wants to execute P2 instruction, that it will clearly halt, or it will clearly what we will say, it will clearly roll back to the process. It will clearly ban the process, that you can't interfere with another process. Your space is this, P1 process is this. If you access in that space, then it is okay. Otherwise, you can't access to the another process. If there is a conflict, or there is any conflict between any two process, then the whole process will not get executed. Okay, so there will be no interfere. There will be no interfere between the processes. If there will be interfere, then the process will not get executed. So this is all about the security and the privacy. I hope you will understand. Security is for the authentication and privacy is for getting the process in that mode that another process can't interfere in that in that background in any state. If there will be interfere, then the whole process will not get executed. So this is all about the functionalities of operating system. I hope you have understand the what are the major advantages the operating system is providing to us. So in these functionalities of operating system, we can easily know about the functions what the operating system is providing to us, and easily understand. This is not the limited of the functionalities, but this is the major functionalities of operating system which our operating system is providing to us. There may be there are different types of much more functionalities, but we can easily say that it is the major functionalities of operating system. Okay. Now the next topic is about how many types of operating system we have. As we are using different hardware devices. So in any electronic device which is managed, which is giving some output, is having some operating system. If we are using any hardware device or any electronic device, it is having some operating system. If we are using computer or laptop, desktop, then we may use Windows, Linux, Macintosh. Okay, so these are the major operating systems which the users are using. There may be more operating system like Unix, which the hardware is required is either it may be computer, laptop or desktop. But if we talk about some mobile devices, then the operating system is changing. Like in mobile devices, we can also use Windows operating system. There are coming some phones which are having the Windows operating system. And Android operating system, very popular Android operating system. Symbian is the version of the operating system. iOS is the operating system which is used in the Apple phones. In different operating system, there are much more versions of any operating system which you are familiar with. I'm just giving some brief introduction about the different operating system, but this is not the types of operating system. This is only the operating system which we are using in our daily life. So I think you must know about that operating system which are used in our daily life system. So Windows, Linux, but in Windows there are not only Windows, there are much more operating systems. Versions of Windows are much more there. They are like XP 2007, Windows 2000, Windows 7, Windows 8. These are the versions. Windows 10. Now the latest is Windows 11, same as it in Windows, same as it is in Windows. There are many in Android operating system. There are many versions like KitKat, Lollipop, Jelly Belly. Okay, so these are the popular operating systems which are using in the Android operating systems, which when you open your phone and go to the about phone, then you will clearly see that which operating system is there and which version of operating system is you are using in that mobile device. So these are the basic devices which we are using. But when we talk about any what are the operating system which we are using in our other devices, just like if we are accessing our AC or microwave or any other devices which are like washing machine, there are operating systems in that also, which are having the set instructions, limited instructions, which can be embedded. These operating systems comes under the embedded operating system. Which in embedded operating system, the basic is this: that there are limited instructions which are encoded in the chip and placed in the PCB plate, and only that instruction will be performed in that device. If we want to cool cool the temperature of any device of AC, then we can easily access through the remote and change the temperature. But we can't use it in the microwave. Okay, in microwave there is another set of instructions which are placed in the chip, which are coded in that format, and it can perform only that task. So in same line as in washing machine, which is also having the same type of instructions, which when we want to use the gentle washing, or we want to heavy washing, when we want to dry or spin, that is done coded in the chip and placed in the format of the washing machine, so that all these devices are running smoothly with the another operating system supports. So this is all about the operating systems of different machines, and we will discuss the types of operating system in the next lecture, and say what are the different operating systems, or what are the generalized types of operating system which we can use in different platforms. If we want to do any task, according to that there are different types of operating system, just like batch operating system, multi-programming, multitasking, real-time operating system, and embedded system, of distributed operating system, network operating system. We will discuss it in the next video lecture, because it is not possible to say about all these operating system in this, because the video will get very long. So I will discuss in the next video lecture. Thank you. This is all about. So thanks a lot. I hope you will understand about something about the operating system which we are using. And these are the versions that thanks all about. Thank you.